You're welcome to Detailed Learners Tutorials. In this video, we shall solve a problem on Hooke's law and elasticity. It's a NECO pass question, and the question is this. It says a spiral spring balance is 25.0 cm long when a 5 Newton weight hangs on it, and 30.0 cm long when the weight is 10 Newton. What is the length of the spring if the weight is 2 Newton? Assuming Hooke's law is obeyed. Alright, so this NECO question is asking us to find the length of a spring, when a particular given weight has been attached to the spring. A weight of 2 Newton was attached to the spring. Of course, you know, Hooke's law states that provided the elastic limit of a material is not exceeded, the extension is directly proportional to the force. So Hooke's law is a law that relates force with what? Extension. It's a law that shows the relationship between force and extension in a proportional way. So in the case of this particular question, we were given a length of 25 centimeters as the first length. Let's call it L1, the first length, due to a 5 Newton force. You must know that the word weight is another word for force. So when a 5 Newton weight or force was attached to the spring balance, the length of the spring balance became 25 centimeters. I would like you to pause at this moment and think. A 5 Newton weight was attached to the spring balance and the length became 25 cm. That means we were never told that the original length of the spring balance was actually 25 cm, but rather we are told that the length became 25 cm because of the 5 Newton weight that was added to it. Now, when the weight now was changed to 10 Newton, the length became 30 cm. So we are now asked, what if we decide to make the weight 2 Newton? What will be the length? Before we move further to solve this question, I would like you to understand that when you are to solve for the extension in a material, you must always make reference to the original length of that material. How do I mean? Let's assume we're having a scale right here. This is scale, and we are having our spring, and a mass can be attached over there, and the spring is connected to this stand. Then on the left hand side, we're having a meter rule that is graduated in meters. So this is a weight attached to this spring balance. Now, this spring balance actually, before the weight was added, the spring balance had an original length of, let's say 5 meters. Now this may not be practical, but we are just giving an illustration. So this is spring. Actually, the spring has an original length of 5 meters before the weight was added. Then when the weight was added, the length of the spring became 8 meters. The length of the spring became 8 meters. Now, what is the extension? The extension is the difference between the new length, which we can call L1, and the original length, which we can call LO. The new length is 8 meters and the original length is 5 meters, so the extension is what? 3 meters. Now we could find the extension because we knew the original length of the spring. Assuming the original length of the spring was missing, we wouldn't have been able to find the extension as a result of the weight which was added. So we must actually evaluate the extension, the original length of the spring, the spiral spring, before we can find the extension at each case. So now let's just analyze the question further in a more detailed way. So you see that L1 was 25.0 cm, and this was as a result of the 5 Newton force or weight, and then L2 was 30. L2 is equal to 30.0 cm, and this was as a result of the 10 Newton force. Now we are now asked to find the length that will be as a result of 2 Newton force. So this means in these three cases there should be an extension. So new length, and the new length is 25.0 cm. It's going to be the difference between the new length and the original length. This will be equal to the first extension, that is as a result of the 5 Newton force. Please make sure you follow it, please, so you don't miss it. Now the second extension, which is going to be the difference between 30 cm and the original length as well, is that which is as a result of the 10 Newton force. The second extension is as a result of the 10 Newton force, and then the third extension will be as a result of the new 2 Newton force, which we are now asked to evaluate the length, right? So we have therefore written expressions for the 3 extensions that resulted as a result of the 5 Newton force, 10 Newton force, and then the 2 Newton force. And like I said before, we are making reference to the original length because we cannot find the extension in a material unless we have to make reference to the original length of that material. That's the only way we can know the extension as a result of a force. Now there's only going to be an exemption if you are asked to find the extension due to an added force. Let's go back to the diagram of our scale. So if this is the original length of the spring, and let's call that length 5 meters once again, and then a weight was added, and when a weight was added, the spring came down to this point. It extended to this point and became 8 meters because a weight was added. Now while the spring is over here, the weight that was added was 5 Newton. And now you are now asked to add an additional 3 Newton weight to this 5 Newton. So that made the new weight to be what? 8 newtons, because 5 plus 3 gives 8. So that eventually brought down the spring to this point. Now if you are asked to find the extension due to the added 3 Newton force, now take note of my words. you are asked to find the extension due to the added 3 Newton force. That will simply mean you should subtract the length at this point, L3, you should subtract, okay, sorry, not the length at this point, from the length at this point, because this will actually be bigger. So you have to subtract the length at this L2 from L3. That is L3 minus L2. Then you will get the extension that is as a result of the added 3 Newton force. It's only on this ground you can make reference to the immediate path length to find extension when you are asked to get the extension due to a specific added force, because that force was added to the previous one. So that is why we are making reference to the previous length to get that extension. Hope that's clear. So in this other case, which as in the one we are given in the NECO question, we have to solve it this way. We'll make reference to the original length to find the extension. Now I want to draw your attention to the equation of Hooke's law once again. Hooke's law has an equation which is this: force over extension is equals to a constant. Force over extension is equal to a constant. Just watch out for a video for a proper explanation of the meaning of Hooke's law. Then I'll explain what this actually means. All right. So now, since you're seeing that force over extension is equals to a constant, this means that even if we're having a new force, F1 over E1 and a new extension, it will also give us the same constant. So let's make use of this formula. To find the value of the constant. When we can find the value of the constant, then we'll be able to find that length which we're asked to find, which is the length due to the 2 Newton force. All right, so to find the constant, we are going to adopt one of these expressions which we have over here. We're going to adopt one of these expressions. So let's adopt the first one. So the first one talks about the first force, which is F1, and then the first length, which is what? L1. So adopting that expression, we are going to impute the values in this equation. So F1 was given to us as 5 Newton, and then the extension E1 is what? L1 minus LO, and this gives us K. So let's just put the values again. F5 Newton is all over L1 is 25 minus LO. This gives us K. So this becomes our first expression for elastic constant due to the first force. So we are going to also get an expression for the elastic constant due to the second force, which is 10 Newton, and the second force, 10 Newton over the length that resulted was 30 minus the original length. That gives us the extension there over K. So this is an expression of the elastic constant that is due to the second force of 10 Newton. So if 10 over 30 minus LO is equal to K, and also we are seeing that 5 Newton over 25 minus LO is also equal to K. What does that simply mean? That means that 5 Newton over 25 minus LO can be said to also be equal to 10 Newton over 30 minus LO. You can pause and think about this. So equivalent fractions, equivalent expressions, because both expressions are equal to K, so we can say they are equal to each other. Now we are going to solve further. So solving we are going to simply cross multiply, and when we cross multiply, 5 will go into 30 minus LO, and that should be equal to 10 going into 25 minus LO. So opening the bracket, 5 times 30 will be 150, and we have 5 LO. This will be equal to 10 times 25 will give us 250 minus 10 LO. Now we are going to move all the expression, all the terms that are alike, we'll move them to one side of the equation, and just like that, and that process is called collected line terms. So we're going to move this to this side and move this over to this side, because this expression is having LO. So moving this 250 over to this side, the sign attached to it will change to a negative. So we have 150 minus 250 equals minus 10 LO. Similarly, the sign here will change to positive sign once it crosses this equality sign, and that becomes plus 5 LO. So eventually we'll be having minus 100 equals minus 5 LO, and at this point divide both sides by 5. So dividing both sides by 5, we have not just 5, minus 5, because the sign must go with it. So dividing both sides by minus 5, this will be the result. So minus 5 takes out minus 5, and then the negative sign takes out the negative sign to give us a positive sign, and then 5 goes into 100, and that gives us 20. So the value of our constant is what? 20. And remember, our unit is not our constant, the value of our original length is 20, and we are working with centimeters, so 20 centimeters is the value of our original length. Now, since we have known the value of the original length, we can now get the value of the constant. Now remember that our first expression for the constant was 5 newtons over 25 minus LO. That was our first expression for the constant. So we are going to substitute the value of LO into this expression. That will be 5 over 25 minus 20 equals to K. So this simply implies that K is equals to 5 over 5, and 5 goes into 5, so that means K is equal to 1 Newton per centimeter. 1 Newton per centimeter. And since we now have a value for the elastic constant as 1 Newton per centimeter, we can now go ahead to get the value of the length that will be as a result of 2 Newton force coming on the spiral spring. So when 2 Newton force comes on the spiral spring, there will still be an extension, and the ratio of the force to the extension will be equal to 1 Newton per centimeter. That's what it simply means. Okay, so the force now is what? The force now is 2 Newton. So 2 over extension. Remember, the extension now will be the difference between this length as a result of 2 Newton minus the original length, which is 20, and that will be equal to 1 Newton per centimeter. So we'll cross multiply again, and when we cross multiply, we have 2 will be equals to L2 Newton, that is the length as a result of 2 Newton minus 20, and so the length as a result of 2 Newton will be 2. Bringing this over to this side, the sign will change to positive when it crosses the equality sign. So we'll be having 2 plus 20. So the length is what? 22 centimeters. So if you are to leave your answer in meters, you convert 22 centimeters to meters by multiplying it by 10 raised to the power of minus 2, and this will give you 0.22 meters. And just for the previous one also, if you convert 1 Newton per centimeters to Newton per meters, we'll be having 100 Newton per meters. We're having 100 Newton per meters, and you can do that by converting this extension from centimeters to meters, and that will be 0.05. And when you divide 5 by 0.05, you get 100, and that will now be 100 Newton per meter. So this is the solution to the question. The length that will be as a result of not an added, now a new force of 2 Newton. A new force of 2 Newton will be 0.22 meter. It's a new force because every other weight was removed, and then the new weight of 2 Newton was brought in. So the extension now dropped to 0.22 meters rather. 0.22 meters. Hope you enjoyed the video. So if you like this video, I would urge you to please subscribe to this channel to get more exciting, detailed and expository videos like this, and share these videos with your friends, loved ones, well-wishers, so they too can have such videos to learn from. So just hit the subscribe button. It's free of charge. Just hit it so that you can get notifications on other videos when they are being uploaded on this channel. Also, I would like you to just press the like button, the thumbs up. Just give it a thumbs up and like this video if you actually enjoyed it, and also share it with your friends. Okay, until our next video, stay blessed, and remember that Jesus loves you.